today. So now we'll go on to looking at some analytical techniques. And so these are the techniques which are used to identify various different compounds and molecules in chemical applications. So the first one we're going to be looking at is chromatography. And so with chromatography, we have many different types of chromatography. So we're going to be starting off with looking at thin layer chromatography. So as we can see on the screen here, we have a diagram that represents thin layer chromatography. So basically, thin layer chromatography is our most common type of chromatography, which we look at in the QCE syllabus and in this particular type of calculations which you would want to be doing. So basically what thin layer chromatography does is, thin layer chromatography uses a solid stationary phase, which is known as a plate. So that's what can be seen where those dots are traveling up. And it uses a liquid mobile phase, which is a solution which is placed in the bottom of the beaker. So we can see that on the screen there, where the light blue color is seen to be the solid stationary phase, which is the plate, and the surrounding grey area which the plate is placed in is the liquid mobile phase, which is obviously our solution in the beaker. And so in thin layer chromatography, molecules in the thin layer chromatography are separated on the basis of polarity. And so this uses capillary action, in which the liquid phase is slowly moving upwards through the solid phase. So in order to do this, you need to have a line drawn about 1 centimeter from the bottom of the solid phase. And at this line, which is drawn from 1 centimeter at the bottom of the solid phase, you want to add a small dot of your sample. And so typically that sample will be a hydrolyzed protein sample. So where you've taken an unknown protein and you've broken it down in a hydrolysis reaction into its separate amino acids. And so when you break it down into its separate amino acids, those amino acids will be able to be separated through this thin layer chromatography. And so basically you add a small dot of this sample on that 1 centimeter line, and you can do multiple different samples along the line as long as they are far enough away from each other that they're not going to be mixing together. And then basically what happens is, as the mobile phase is pulled up through the plate through capillary action, so because there's fine little pores through the solid phase, the liquid can be pulled up through the beaker. The sample which you've put onto that 1 centimeter on the stationary phase is pulled up along as well, and at different rates depending on the polarity of each of those different molecules. And so basically, if the sample contains multiple different molecules that have different polarities, they'll be separated because those molecules are going to be pulled at different speeds. And so that's going to be fully dependent on the polarity of the liquid mobile phase. So if the liquid mobile phase is polar, then the polar molecules in the sample will be more attracted to the liquid phase. Whereas if it is a non-polar, then the non-polar components of the sample will be more attracted to the liquid mobile phase. And so this is going to cause that difference in speeds at which they are moved through the sample, and will thus separate them, as we can see here in the diagram, where we've got all of these colored dots which have traveled in different distances. And so once the mobile phase, so that sample which we had in our beaker, which didn't have the proteins in it, the one which was used as our solvent, once that has reached the top of the stationary phase, the plate gets removed, so our stationary phase gets removed from the solution. And so now we need to measure the distance between the 1 centimeter line drawn at the bottom and the highest point on the mobile phase that has been reached, as well as the distance between the line and each dot that's seen along the length of the plate, or each dot from the sample which we see along the plate. And so when you divide, we can see here we've got this calculation which we can do here, which is called the retention factor, or RF factor, which we can calculate. And so this can give us a value which can make us understand a constant for any particular molecule. And so we can divide the distance traveled by the component divided by the distance traveled by the mobile phase or by the solvent. And so this will give us the retention factor. And so our retention factor is going to be constant for any particular molecule, which means that no matter what protein it is, if it always has one of the same amino acid in it, that one particular amino acid will always result in the same retention factor. And so this allows us to then determine unknown proteins in a sample, and hence is very useful for identifying unknown solutions. So that's thin layer chromatography. Our next one we're going to be looking at is called column chromatography. And so column chromatography goes on the basis of a similar concept where we have basically the reverse of thin layer chromatography. So the solid phase is the column packed with silica beads, and they're going to be acting the same way as our solid phase in the thin layer chromatography. And then the liquid phase is mixed in with the sample and is added to the top so that it can all flow down through the column, so flowing down through all of those silica beads. And basically the samples will then, yet again, be separated out based on their polarity. And so what we'll notice in this is that the molecules with the stronger interactions with the silica will flow through the column more slowly when we open the bottom of the column. And so this will mean that we can physically separate out the molecules from other molecules that have different properties, and we can then use those for different tests to further analyze them and determine what they are. And so often this is done when we have a sample that has a number of various different chemicals in it, and when we're only interested in determining one or a few of those particular chemicals. So if there's particular components in there which we completely want to disregard, then we may use this concept of column chromatography. This means that we can then get a more pure sample of the chemical of interest, and then we can then go on to use these samples for more specific analyses, or we can test them to then determine different properties about the chemicals which we may then use to determine their nature. And so that's column chromatography. So our next one we want to look at is known as gas chromatography. And so gas chromatography is a lot less commonly used, just because it's a lot more of a complex process, as we can see from this diagram here. So with gas chromatography, it uses a lot of computerized techniques and changes in pressure to help us determine unknown compounds or unknown substances. So in gas chromatography, the samples are vaporized, and with the help of a carrier gas, so often that will be like hydrogen or nitrogen, it gets forced through a detector, which is like what we can see in this section over here. And so a beam of light is then used, and this is shone at the sample through this section in here. And basically what happens is when the light is shone through this sample, we can then measure the light which is being absorbed by the sample, and measure how much light is being reflected as well. And so molecules with a lower boiling point are going to come out of the machine first, and molecules with a higher boiling point will come out of the machine last. And so basically this is just separating molecules on the basis of their boiling point. And as we know, boiling point is correlated with polarity, is because it's correlated with intermolecular forces. And this can also then provide us with a pretty accurate representation of concentrations of each separate molecule as well. And so that's just because we are fully separating them out. And so because each molecule is going to have a distinct boiling point, we can then determine that there's a larger quantity or a smaller quantity of each specific one being produced. So that is gas chromatography, and that sums up all of our main chromatography techniques which we need to know. So the chromatography techniques which we need to know, remembering, are thin layer chromatography. So that is our most common type. So that was our first one which we looked at. Our next one which we looked at is used a bit less commonly, and so that is column chromatography. And so that was separating it using the silica. And then our final one which we looked at was gas chromatography, and this one is used a lot more in industrial settings and in large laboratory situations, and is very reliable and can tell us a lot about concentration, but is obviously a lot more difficult process to carry out as it requires a lot of more equipment and computerization.